A pleasant day to the young and enthusiastic learners. I am Dr. Shobha, Principal, Associate Professor and Head of the Department of Corporate Secretaryship, KCS Kasinada College of Arts and Science, here to present on classification and tabulation of data. So statistics actually deals with data, and the data that we have has to be first classified and tabulated for further analysis. So while tabulating and classifying the data, we will go into the following steps. Classification of data is nothing but grouping the data into classes. So we are actually sorting the data. So that is classification of data. And tabulation is putting the classified data into the form of a table. So when the data that we have sorted is put into a table, it's called as tabulation. What a frequency table is? A frequency table is a one-way table which displays the number of occurrences a particular value or characteristic has. So the number of times a value appears is shown in a frequency table. Diagrammatic representation is nothing but a visual representation of the statistical data. So when we present the statistical data in the form of a diagram, curve, chart or picture, it is called as a diagrammatic presentation of data. When it comes to class interval is nothing but when we group data, it is grouped into classes. So each class is called a class interval. So take for example 0 to 10, 10 to 20, 20 to 30, 30 to 40. So 0 to 10 is a class interval. 10 to 20 is another class interval. Okay. Now from this class interval we have the class limits. So when we say 0 to 10, the lower class limit is 0 and the upper class limit is 10. So it's nothing but the lower class limit of a class is the smallest data that can be put into the class, and the upper class limit is the largest value that can go into the class. So another example, when we say 5 to 10, 10 to 15, 15 to 20, in the class interval 5 to 10, the lower limit is 5, the upper limit is 10. So qualitative classification is also there. When data is classified on the basis of some qualitative attributes like sex, color of the hair, literacy, religion. So if it is based on any qualitative aspect and the quantitative aspect is missing, it is called as qualitative classification of data. So now in our classification, tabulation, diagrammatic representation and the graphs, we have the simple bar diagram. Simple bar diagram is just a diagram where only one variable is considered. It is a simple bar diagram. A histogram is represented by a bar diagram, but the space between the bars will be missing. So the bars will be adjacent to each other. That is a histogram. So a histogram is nothing but when the simple bar diagram is drawn without space. It is called as a histogram. Then a bar graph is a visual tool that uses bars to compare data. So your graph is drawn for comparing data. A bar graph can be horizontal or vertical. So we can have a horizontal bar diagram or a vertical bar diagram. Now, what is a OGI? OGI is a frequency curve that is drawn for cumulative frequency. So it is nothing but a cumulative frequency curve. So a curve which is drawn for the less than cumulative frequency is called as less than OGI. A curve which is drawn for the more than cumulative frequency is called as more than OGI. A frequency polygon. A frequency polygon is nothing but when you join the midpoint of the top of the histogram. So histogram is one where the bars are adjacent to each other. So as in this diagram, so when you join the tip of the bar of each histogram, So the tip of the bar is joined. It is called as a frequency polygon. So if you join it with a straight line, it is a frequency polygon, and the same line, the same tip is joined by a smooth curve, it is called as a frequency curve. So midpoint of the top of each bar is joined with a straight line, it is a frequency polygon, and when it is joined in a freehand curve, it is a frequency curve. And finally, the x-axis is also joined on both sides to make the polygon complete. A pie diagram. So a pie diagram is nothing but it looks like a pie, and it is like a pie which is cut into slices like a pizza. So that is why it gets its name as a pie diagram. So it is the total that is divided into parts. Now going on to the different types of diagrams, we have one-dimensional diagrams, two-dimensional diagrams, three-dimensional diagrams, pictograms and cartograms. When it comes to one-dimensional diagrams, only one dimension is considered. So there we have a simple bar diagram, a subdivided bar diagram, multiple bar diagram, deviation bar diagram. So all these are one-dimensional diagrams. Then we move on to the two-dimensional diagrams, that is the rectangle, the square, the circle and the pie diagram. And the three-dimensional diagram is nothing but the cube, cone, cylinder and the sphere. So when we go on to the two-dimensional diagrams, both the dimensions are considered, so it's called as area diagram, and that is the length and the breadth. And when it comes to three-dimensional diagrams, it is called as the volume diagram, where length, breadth and height is considered. So those are your three-dimensional diagrams. Now moving on to the object of classification. So we classify data to condense the data and to facilitate comparison, to pinpoint the features just at a glance. By looking at it, you should be able to find out. It gives prominence to important information, and it also helps in statistical analysis. So this is the object of classification. Now we move on to the types of classification of data. The geographical classification, the name itself says it is on the basis of area. So the northern region, the southern region and so on. Chronological classification is based on the time period, that is based on the years or the months or weeks. Qualitative classification, as I already said, it is based on some qualitative attribute like color, religion or some quality. Quantitative classification based on the magnitude or units of measurement. So classification based on frequency is nothing but the individual data which does not have frequency. The discrete series where you have repetition of data, continuous series where the repetition of range of data is there. So discrete series is nothing but, before I go on to the classification based on frequency, I'll just tell you what the types of data are. You have individual data where all single numbers are called as individual data. And when we have a repetition, supposing I have 8, 7, 3, 2, 8. So now this 8 has repeated twice. So instead of showing it as 8, 7, 3, 2, 8, we put it as 8 with a frequency of 2, 7 a frequency of 1 and so on. So when a value repeats, the number of times a value repeats is called as its frequency. So we will have two columns, the x values and the frequency. That is your discrete series. But when you have a range of data, so when you classify based on the class interval, as I already said, 0 to 10, 10 to 20 and so on, and you have a frequency for it, it is called as a continuous series. So when you have individual numbers, that is only x values, it is individual data. When you have x values and the frequency, it is discrete series. When you have the class interval and the frequency, it is called as continuous series. So now, moving on to the formation of discrete frequency distribution. The number of times a particular value is repeated is called the frequency. So while you form a continuous frequency distribution, it is classified according to the class interval. So there are some rules for construction of a frequency distribution. So what we have to bear in mind while constructing a frequency distribution: the number of classes should be limited. It should contain at least 5 classes, not very few classes, 0 to 10 and 10 to 20 and you finish. No. So you should have sufficient number of classes. The frequency distribution should be preferably in multiples of 5 or 10. It's better we avoid 3, 7 and 9. Instead of having 0 to 3, 3 to 6, 6 to 9 and so on, it's better we have 0 to 5, 5 to 10 and so on. The starting point should be the lower limit of the first class and it should be in multiples of 5 and so. So we should include all the values in our given data. So the smallest value should be there and the highest value should be there. Supposing our smallest value is 15, we can start our class interval from 15 to 20, 20 to 25 and so on. And maybe our highest value is 110. So we can go on till 110 or 115 and stop. So this is how our class interval is formed. Exclusive method should be adopted and we should use class intervals which are of equal size. Open-end distribution will not be used. So you should close the class interval. So if it is below 10, you close it with an equal limit. And if it is above 90, maybe the previous class is 80 to 90, the next class should be 90 to 100. So it should be closed. And the size of the item indicated on the left hand side of the frequency are indicated in the right hand side. So this is how you form a frequency distribution. Then you have a bivariate table. That is nothing but the name says, 2 variables, bivariate. When 2 variables are considered and put into a table, then it is a bivariate frequency table. Now, as we already saw, class limit is the lowest and the highest value that is included in the class. If it is 0 to 10, the lowest value is 0, the highest value is 10 that can be included over there. Class interval, the difference between the upper and lower limit. So 10 minus 0 is 10. If your class interval is 10 to 20, 20 minus 10, again 10. So that is the class interval. Class frequency is the number of times a particular value, a particular data in that class occurs. So that is the frequency. Class midpoint, it is the mid value of the class interval. So usually we will be considering the class midpoint as we go further into our analysis of the data. So if the class interval is 0 to 10, it is lower limit plus upper limit by 2. So it is 0 plus 10 by 2. So it is going to be 10 by 2, the midpoint is 5. If your class interval is 15 to 25, it is 15 plus 25 by 2, which is 40 by 2. So the midpoint is 20. Now, the method of classifying data: exclusive method, inclusive method. Exclusive method, the lower limit is included and the upper limit is excluded. It goes into the next class. So if it is 0 to 10, 0 is there, 10 goes into the next limit. So till 9 you will put over here, 10 to 20 will include 10 and 20 will not be included. So lower limit is included, upper limit is excluded. The inclusive method, both lower and upper limit are included. So 0 and 10. Then it would be 11 to 19. So this is how the class interval will go in inclusive method. Okay. So both the lower and the upper limits are included. That is inclusive method. Now the difference between classification and tabulation. So this is on the basis of the meaning. Classification is grouping data and based on the similarity of characteristics. Tabulating is summarizing the data that is classified, and this classification is done after collection. Tabulation is done after classification. It is arranged based on attributes and variables, and tabulation is in rows and columns. And classification is for analyzing data. Tabulation is to present the data. So for this you have categories and subcategories of classification. Tabulation has headings and subheadings. So this is the difference between classification and tabulation. Now the characteristics of a good table. So when you go on to a table, it is according to the purpose, according to the originality, according to the construction. So a good table should be concise. So when you have a tabular column, it should not be very big. So it should be concise. It should be suitable to the size of the paper. It should not go outside the paper. Captions should be arranged alphabetically. So every column, every row will have a caption, will have a title. So it should be either alphabetical, numerical, geographical, or any traditional method. The units of measurement should be clear, whether it is in meters, kilometers, kilograms, whatever units of measurement. The total should be written within double lines. It should not be overloaded. A table should not be overloaded. There should be columns for miscellaneous items. For other items also, there should be a column. Abbreviations to be avoided, and zero should be used instead of not applicable, because when we go in for our analysis, only when the value is there, it will do the calculation. You will be able to do the calculation. So not applicable or hyphen. So it's better you avoid those words, or ditto. All these are to be avoided, because sometimes ditto may look like 11. Impartial information is not allowed. So totally correct, complete information should be there. So common attributes of similar nature will help in comparison. So that is it. You should avoid fractions. Percentage or ratios can be shown, calculated and shown. So now here is a blank table for candidates. So we are considering the sex of the candidate and the faculty. So this is a two-way table, a bivariate table. So the faculty of arts, science, commerce, first year, second year, third year, male, female, and male, female. This is how you draw a table for while considering two variables. So this is a bivariate table. Now they want us to make a frequency distribution taking class intervals as 30 to 40, 40 to 50, 50 to 60. So they themselves have given us the class interval. So we are considering the class interval which is given. So we start with 30 to 40, 40 to 50, 50 to 60, 60 to 70, 70 to 80, 80 to 90 and 90 to 100, because they have asked us to start with 30 to 40. So we've started it so, and we have values as 95. So we go on to 90 to 100. Now to make a frequency table, we have to put the tally marks. So tally marks are nothing but the small slashes. So we go one by one. 40. So 40 is in the second class. So draw a slash. Then 36, which is in the first class. 43 in the second class. 57 in the third class. Then 81 between 80 and 90. So draw a slash. Then 90 in the last class interval. So draw a slash. 92 also in the last class interval, draw a slash. Then 74 within 70 to 80. So go on like this with the slashes. So when you draw these slashes, when you have 4 slashes and the 5th slash has to be drawn across, so that it will be easy for us to count. So always when we put the tally marks, we will put 4 slashes and the 5th slash will go across. After we finish the last value 80, we put the tally mark. In this class interval, we start counting. 3, 5 plus 1, 6, 5 plus 1, 6, 5 plus 2, 7, 5, 8 and 5. So our frequency distribution is formed. So this is how we do. If they give us the class interval, we use the class interval that is given. Otherwise, we use our own class interval which will suit the data that is there. And then we put the tally and finally pick out the frequency, count the frequency from the tally. So a similar sort of a question, but this is a two-way table, a bivariate table. And here also they give us saying the class intervals are 10 to 20, 20 to 30 and so on. So 10 to 20, 20 to 30 and so on to include all the values. And then 100 to 200, 200 to 300, the y values. So now it's a bivariate table. So 41 in x and 518 in y. So 41 in x comes in this and 518 comes over here. So put a slash over here. Next, 14 and 148. So 14 is in this class interval and 148 should be over here. So we put a class and tally mark over here. Then 20 and 242. So 20 is over here, 242 in this. So 20 and 242. 20 will be in 20 to 30. 242 will be in 200 to 300. So over here we put the tally mark. And so on, we fill in all the tallies and then count and write. Same tally mark applicability applies over here when you draw 4 tallies and you have the 5th one, you draw a line across. Then count the tallies and fill in the frequency. So this is how you do a two-way table or a bivariate table where you consider 2 variables. So a histogram, I already told you, it's a column diagram, it's a bar diagram with no space in between. So when you want to draw a histogram as an example, the bars should be drawn together. So when I put the midpoints of the top, I join it. I think you should be recollecting. It is a frequency polygon if it's with a straight line. If it's with a smooth line, it's a frequency curve. And then here we represent by a pie diagram. So this looks like a pizza cut into slices, a pie cut into slices. So before going on to a pie diagram, they've given us the items, the food, clothing, recreation, education, rent and miscellaneous, and they've given us the expenditure. So what we have to do is put the total of the expenditure. Convert the expenditure into degrees. So 87 rupees to be converted into degrees, what you have to do is 87 divided by the total, that is 180, into 360. The total degrees is 360. So 87 by 180 into 360, which will give you 174 degrees. Then 24 by 180 into 360 will give you 48 degrees. 11 by 180 into 360 will give you 22 degrees and so on. So now with these degrees we draw the pie diagram. So with your protractor you draw the pie diagram for all these degrees, and the last portion with 40 will end over here perfectly. The total 360 degrees will be covered in the pie, and you have to give an index for the coloring of the different items. For food, the clothing, recreation, whatever colors you have used, to be given by an index. So this is how you represent the data as a pie diagram. Now rules for constructing a diagram. So diagrammatical representation is a visual form of presenting data. So we are visualizing things. So diagram should have a title. The width and height should be appropriate. The width of the diagram, the height of the diagram should be suitable. Then there should be appropriate scale. There should be some footnotes, some index that you give, and neatness, cleanliness, only then it will be attractive, and the diagram should be simple. Difference between a diagrammatic and representation and tabulation. Tabulation more precise, but diagrams less accurate. You can't draw the decimals in a diagram. More information is there in a table, But in a diagram, it's attractive, but the information is less. But tabulation is less attractive, diagrams are more attractive. And tabulation, it takes some time for us to interpret. Even when you have the cricket match, if it's given at a tabular column, by the time you see the scores and your interpretation goes on, it takes time. But when they draw the graph, you know what the score, what projected score is after the 30th over. So this is how it is easy to interpret when you have diagrams or graphs. Now, the various diagrams, the uses of diagrams, the significance of diagrams. Diagrams gives us a bird's eye view. It is very attractive. Memorizing effect, once you look at it, you can have it memorized, and the diagrams facilitate comparison. When we move on to the usefulness of diagrams, used for creating interest, because it can all be visualized at a glance and comparison is easy. Diagrams are used for those who don't want much of the details, and it plays a major role in modern advertising, and it is used for analyzing complex data. It helps in locating statistical measures like median, mode, quartile, correlation, regression. For all this, you can represent diagrammatically. Graphic representation, the most convenient and popular way of describing data, is the graphic representation. It is easy to understand and interpret when they are represented graphically. A graph can present data in a simple and clear way. So, graphs are easy for analysis and presentation of data. It is attractive and effective presentation of data. It is simple and understandable, and it is useful in comparison. So, now the advantages of graphic representation. It's useful for interpretation. It has a memorizing effect for a long period, helps in predicting the future. Universally, it is utilized, and information as well as used for entertainment, and helps in transmission of information, and there is no need for training, no special training needed for interpreting graphs. Now, the graphic representation, you have graphs for time series or line graphs, and you have graphs for frequency distribution. So, when it is graphs for frequency distribution, there comes a histogram, frequency polygon, frequency curve, and the cumulative frequency curve or the ogive. Histogram, we already saw, is a column diagram. Frequency polygon also, I said, when the midpoint of the top of the histogram is joined with a straight line, it's a frequency polygon. When the same midpoints of the top of the histogram is joined with a smooth curve, it is a frequency curve. So, when we have graphical representation, it is the most convenient and popular way of describing data, and it is easy to understand and interpret data when it is presented graphically. A graph can present data in a simple and clear way. It can also illustrate the important aspects of the data. This leads to better analysis and presentation of data. So the ogive, which we said, we have two ogives, the less than cumulative frequency curve, which is the less than ogive, the more than cumulative frequency curve, that is the more than ogive. So when you draw it for the cumulative frequency, it is the cumulative frequency curve or the ogive. So what is this cumulative frequency first? So when you have x values and the frequency, or when you have class interval and the frequency, your frequency may be, for example, is 5, 3, 2, 1. So when you write the first value as it is and you start adding the values, so 5 first value is 5. The next cumulative frequency, 5 plus 3, 8. 8 plus 2, 10. 10 plus 1, 11. So this is your less than cumulative frequency. So when your values are added from the top, 5, 3, 2, 1 was the frequency, and my cumulative frequency is 5, 8, 10, 11. So that is a less than cumulative frequency. More than cumulative frequency, you add from the last value. So 5, 3, 2, 1. So 1 is written as it is in its place, and you add 2 to it, it becomes 3. You add 3 to it, it becomes 6, and you add 5 to it, it becomes 11. So your cumulative frequency will be 11, 6, 3, 1. So when it is added from down, it is more than cumulative frequency. When it is added from the top, it is less than cumulative frequency. And when you draw a curve to it, it is a less than ogive or a more than ogive. So with this, we have a basic introduction of your tabulation, graphic presentation, and diagrammatic representation, the introduction to them. So thank you and happy learning and have smart learning. Thank you again.